Assalamu alaikum. With the name of Allah who is most beneficent and merciful. Today I am going to discuss a topic from PRC. The topic is types of steel failure. There are three types of steel failure. The first one is under reinforcement tension failure, and the second one is over reinforced or compression failure, and the third one is balanced design. When we design our PRC design, then it is very important to calculate the proper amount of steel in our structure. If we provide a large amount of steel, then it is problematic. Same when we provide less amount of steel, then it is also problematic. So it is very important to provide a proper amount of steel in our RCC structure. Today I will only discuss under reinforcement or tension failure. The other two types will be discussed in my next video. So before going to discuss under reinforcement or tension zone, we should be clear about steel ratio and effective depth. So what is the steel ratio? We denote it with the symbol rho. It is a ratio between area of steel to the effective area. It is a unitless quantity. Area of steel, the steel bars that we use in our member, and the effective depth. Effective depth is the distance, is the height from the tension member to the upper compression member. So it is the effective depth, it is the width of the beam, and it is the height of the beam. So by taking a ratio between area of steel to the effective depth, that is D, we can calculate the steel ratio. So after this, moving toward under reinforcement tension zone. When we provide the steel, our steel in our structural member in a less quantity, then it will fail at the end in the form of yielding. The tension zone, in the tension zone, the member will face the three different stages before failure. The stage 1 is the neutral axis and the lever arm remains constant in this zone. This is the tension zone and this is the compression zone, and this is our neutral axis. In the start, the lever arm, the distance between the tension zone and the compression zone is known as lever arm. In the stage first, the lever arm remains constant, and the neutral the position of neutral axis also remain constant. But in our stage 2, the neutral axis, the depth of neutral axis from the compression zone will decrease, and the height of lever arm will increase, and also the cracks will be produced in this tension part. Because it is a under reinforcement tension failure. So in this, the final breaking of the member is yielding. So due to yielding, the steel will require more space, and it will exert some force on the concrete. Due to the force, the concrete will start to break. So it is the main reason for the cracking of the concrete. In our stage 3, the height of lever arm and the position of neutral axis remains the same, but in compression zone some cracks will be produced. And here in stage 2, the compressive force and the tensile force will be increased. But here in stage 3, the lever arm is not constant, and the compressive force, the magnitude of compressive force will be equal to the magnitude of tensile force, and the lever arm is constant. So if we calculate the moment of resistance, that is MR, we can also take it about C and also in about T. If we calculate it about T, then the product will be C into LA. So this is the moment of resistance about T. But if we calculate it about C, then it will be just like T into LA. It is about C. So in both cases the result will be same. In the stage 2, the moment of resistance will increase due to compressive force and due to tensile force. But in stage 3, the compressive force and the tensile force becomes the same, and the moment of resistance will increase due to the lever arc. So this is all about under reinforcement tension failure. So I will discuss the other two types: over reinforcement compression failure and the balanced design, and there also the derivation of this type. I will discuss all of these derivations and the explanation in my next video. Thank you.